All right, as promised, we're going to make some two-way tables ourselves, just given the information that we have over here. So we have two frequency or tally charts over here that we're going to turn into a two-way table. Now we can see that they're broken up by age group, 12 to 13, 14 to 15, 16 to 17, for both those who ride the bus and for those who do not ride the bus. So let's take a look at how we're going to set up this two-way table. We could do it a couple different ways. So we could put the ages down the left side and then whether or not they ride the bus across the top, or vice versa. Ages could go across the top and the whether or not they ride the bus could go down the left side. Since the ages are already kind of over here on the left side, I'm just going to stick with that for mine. So we've got 12 to 13, 14 to 15, and 16 to 17. So those are their ages. So since those are on the left, then I have two columns that I'm going to make, whether they ride the bus or do not ride the bus. And now I want you to complete this table, so pause the video and fill in those numbers. So for 12 to 13-year-olds, how many ride the bus? We got 5, 10, 15, 20, 24. How many 14 to 15-year-olds do? 12. And how many 16 to 17-year-olds do? 14. How many do not ride the bus? So from 12 to 13, we've got 16 kids there. From 14 to 15, we have 13 that do not ride the bus. And from 16 to 17, we got 5, 10, 15, 20, 21. All right, I want you to calculate the marginal frequencies, so the totals for both the rows and for the columns. All right, we can see that we have 40 kids from 12 to 13. We got 25 14 to 15-year-olds and 35 16 to 17-year-olds. Now, it's split evenly. 50 of the kids ride the bus. 50 do not ride the bus. Interesting. Now, I want you to just look at that table and make sense of those numbers. What do you notice? What's surprising? What isn't surprising? All right, hold on to that thought, because what we're going to do now is we're actually going to calculate some percentages. So for the question in letter A, it says for each group, so for each age group, what percent of the students ride the bus to school? What percent do not ride the bus to school? So for each age group, we got to figure that out. Each age group. I keep saying that. You're probably sick of me. But we are looking across the table. So how many 12 to 13-year-olds do I have? I've got 40. So to figure out what percent ride the bus, what percent of 12 to 13-year-olds, I would take 24 out of 40, because there's 40 kids in that age group. All right, so I'm going to go ahead and erase that. That's the fraction, though, how I would figure it out. 24 out of 40, 12 to 13-year-olds. Well, 24 out of 40 is 60%. So I'm writing my percentages in red. Now, you could do 16 out of 40 to figure it out, but how many kids would there have to be total in the 12 to 13 age group? 100% of the kids, right? So if 60% ride the bus, 40% do not ride the bus. But if you'd rather go the fraction route, 16 divided by 40 also gives you 40%. All right, now we have to do that for every single age group. So 14 to 15-year-olds, we have 12 out of, how many total in this age group? 25, right? So 12 out of 25 kids ride the bus. 12 over 25 is equivalent to 48%. Well, out of 100% total, 100 minus 48, this would be 52. Or again, if you'd rather, you can do 13 divided by 25 and you would still get 52. Either way, however you want to think about it. All right, we've got our last age group. 14 out of the 35 16 to 17-year-olds ride the bus. 14 out of 35, or 14 divided by 35, is 40%. And then we have 21 out of 35, or the other part of the 100%, which is 60%. Okay, now I asked you earlier, what do you notice about this information? What do you wonder? What surprises you? What doesn't? That's our second question. Looking at that information on the table, those percentages probably mean more to you than just numbers, because it's easy to see, oh, the majority of 16 to 17-year-olds, 60%, don't ride the bus. Now, why does that make sense? What happens when you're 16? You get to drive, right? You got a license. So that makes sense, and why the majority have to ride the bus from 12 to 13. Now, it's split down here in the middle. And in the past, I've had kids say, well, maybe they still can't drive, but they might have friends now in high school that pick them up, so they don't have to ride the bus. This is where your interpretation comes into play. This is why I love this so much. Okay, I want you to create an entire two-way table on your own. So go ahead and pause this video. Make sure that you calculate the marginal frequencies. All right, hopefully your completed table looks something like this. So 6th graders, 11 pack their lunch, 9 buy their lunch, for a total of 20 6th graders. 23 7th graders pack a lunch, 27 buy a lunch, for a total of 50 7th graders. And 16 8th graders pack a lunch, 14 buy a lunch, for a total of 30 8th graders surveyed. Now, it says that you randomly surveyed students in a school. So it just so happened that your survey, you got mostly 7th graders in that random survey. Now, what do you think? Does that really represent the entire school? Maybe there are more 7th graders in that school. I'm not sure. It could. But typically, we'd want these numbers to be more even. So a stratified random sample might be a better case if we would group them on 6th grade, 7th grade, and 8th grade to make sure we have a more even amount of those students. It just depends. Now, if we look at the pack and the buy, we can see that the number of students is really split about 50-50 for those who pack their lunch and for those who buy their lunch. Okay, for part B, it says for each grade level, what percent pack a lunch, what percent buy a lunch. Organize the results in a two-way table. So this time I left a little bit of room to make it easier on myself so I could go ahead and calculate those percentages and write them right in the table. So how many pack a lunch? Well, 11 6th graders out of how many total? 20. That's why we calculated those marginal frequencies. Well, 11 over 20 is 55%. Now that would leave 9 over 20 to be 45%, right? Because it's got to be 100% going across grade levels. But if you calculate 9 over 25, or 9 divided by 25, or 9 divided by 20, excuse me, you would get 45%. So either way you want to think about it, go ahead. All right, these next two, for 7th graders, we have 23 out of 50 total, which results in 46%, right? Out of 100. And then we have 27 out of 50 total, which is 54%. And then for our 8th graders, what percent pack a lunch? We have 16 out of 30, so 16 divided by 30. This one I'm going to round, and if you actually use a calculator, we get 0.53 repeating, so I'm going to round that down to 53%. And then 14 out of 30 leaves us with about 47%. We'd have to round that one up. And again, these percentages just help us interpret the scenario, because instead of just looking at, 23 7th graders, 27, we can see that, that's about split half and half, right? 46 and 54%. So, letter C is that interpretation piece that I've been talking about. Does the table in this part show the relationship between grade level and lunch choice? Do you see a relationship? Honestly, it's split pretty even, right? 6th graders, almost half pack, almost half buy, a few more pack. 7th graders, it's about half and half as well, and 8th graders, it's about half and half as well. So we can see that it's really about split down the middle for how many pack a lunch and how many buy a lunch. All right, this is our last example. I want you to answer all of these questions. So go ahead, pause here. All right, letter A, how many people surveyed speak more than one language? So the question is, do you speak more than one language? Yes, that would be these people. So how many total? That's where those marginal frequencies come into play. 12 and 4 would be 16 people total. For letter B, how many surveyed had never traveled outside the U.S.? Never outside the U.S. So again, this is another marginal frequency. Have you been outside the U.S.? That's no. So that is also 16 people. And then lastly, how many people only speak one language and have traveled outside the U.S.? Only speak one language and travel outside the U.S. So answering this question, do you speak more than one language? You would have to say no, because that means you only speak one language, correct? But the second half of this says, and they have traveled outside of the U.S. So traveling outside the U.S. is the yes column, and we can see that they overlap here at 18 people. So 18 people can in fact, or have in fact traveled outside the United States, but they only speak one language. That's that joint frequency that we've been talking about. All right, that is a wrap for lesson 9.3. So you can go ahead and do the homework for this one.